Imagine this lock is a disease. And imagine this key is the cure. Opening the lock means finding the right treatment. But here's the catch, you're not faced with just one key, but millions of them. Now, you could be trying one key at a time. That's kind of what researchers have done up until now. Or you can predict which one is the right key using artificial intelligence.
AI has the power to massively accelerate the discovery of new treatments.
AI drug discovery companies.
AI-powered tools to accelerate drug discovery.
Scientists around the world are using AI to discover new medicines. And in the process, they could be unlocking the secret to a longer, healthier life.
Aging can be targeted, aging can be delayed, and aging in certain ways can be stopped and reversed also.
So what exactly is AI drug discovery? And could it help us live longer?
I'm interested in utilizing AI as a tool that can solve biomedical problems.
With AI, you can increase the probability of success and also make it cheaper and faster.
Vanessa and Alex are two researchers working on one of the most promising applications of AI to healthcare.
Drug discovery.
Drug discovery.
Drug discovery consists in finding new medications to treat diseases. In this case, we're focusing on diseases caused by proteins, like osteoarthritis, Parkinson's, or Alzheimer's disease, and on medications based on molecules, like ibuprofen, paracetamol, or Viagra.
Those small molecules that bind to those proteins and disable them, or disable their expression, and that modulates the disease.
And because the process is partially repetitive, it can be partially automated.
The idea of utilizing a computer to aid the drug discovery process is not new. It's something that has been tried for many decades before.
But AI goes beyond automation. It predicts. It looks at good candidates, understands common features, and predicts other good candidates. But you could also take it a step further.
Imagine a new key from scratch with the desired properties. So you create a set of perfect keys that all of them fit the lock.
Some molecules discovered with AI have already entered clinical trials, and the field is attracting billions in investments. So it's clear that the approach is very promising. But there's more. Some researchers are looking for a cure to something that most of us don't even consider a disease: aging. What is aging? Why do we age? Do we have to age?
Aging is a biological process, okay? Is it inevitable? Well, we cannot delay death, but we can do something about aging.
This is Nir Barzilai, a groundbreaking researcher in the science of longevity.
One of the things that happen when we cross the age of 60, we're starting to accumulate disease after disease and treatment after treatment for diseases that were not part of our evolution, right? People didn't die from dementia or from cardiovascular disease.
And here's the paradigm shift. Instead of curing each disease that comes with aging, why not cure aging itself and hence eliminate all those diseases?
Aging is the mother of those diseases, okay? They lead to those diseases. Those diseases don't happen when you're young.
There are many approaches to curing aging. Vanessa is working on senescent cells.
One of the things that happen with aging, we accumulate what's called zombie cells, or we call them senescent cells, that when they accumulate, they cause an environment to age and get diseases.
We want something that kills only the bad cells. But there are very few senolytics known.
That's a class of molecules that can kill senescent cells.
So the idea is that we thought, why not utilize AI to try and find these drugs faster?
And they did. Vanessa, her team, and AI found what may be the most promising senolytic ever seen. So will AI make us live longer? Well, let's have a look. Finding the right molecule is only the first step of the drug discovery process. To understand how the whole process works, we're visiting a lab here in Berlin. We meet with David Bushiri for a peek inside his lab in Berlin. He and his team walk us through the main stages of drug discovery.
Actually, you don't know what most of molecules are doing, right? There are maybe just a few thousands of molecules where you actually know what they are doing on cells and on the human body. But there are many, many more molecules available, right?
The first step is to decide which molecules to test.
You just test many, many compounds as much as possible to see if they will be active on this disease.
So, now I can show it.
There's 170,000 molecules in the freezer.
Exactly.
Okay, wow. And these little dots that we see, each one of those contains a molecule.
Exactly.
This machine moves the molecules on the proteins they want to target.
So then now the compound plate is finished, it's ready. And now comes the actual transfer.
Next up, this other machine uses a powerful microscope to capture their interaction. Wow, it looks so weird. It looks like an alien.
That's how you look inside. I come actually after this, so then because if you do this kind of experiments, you might end up with a lot of data. Here in this lab we are, for example, collecting sometimes like tens of thousands of images, and a human couldn't possibly analyze all of this, and this is then basically where the machine learning can step in.
Neural networks scan the images to find good candidates.
For example, here we have a lot of antibacterial agents which are clustered together, right? If we have another molecule where we don't know actually what kind of pharmacological activity it has, and we see that it's really close to antibacterial agents in this space, we can then also maybe think this is as well an antibacterial agent.
But every prediction AI makes still needs to be tested. Once you have discovered molecules that you think are promising, then you have to come back here and test them again on the real world, on an actual lab. And the journey doesn't end there. Even if the in vitro tests confirm the predictions made by AI, there are still many steps necessary to ensure that a drug is safe and effective.
If you then want to go to the market and actually sell it, of course, then you go to the clinical trials.
Clinical trials take a long time, and there's little AI can do to speed up that part of the process. AI is a disruptive technology, but not a fountain of youth. At least for now, it can only speed up the first step of the drug discovery process.
I do not think that this is a miracle or something of this sort. If everything goes according to plan, for certain longevity-related diseases, there will be senolytics available for patients to take in the next 10 years.
But there are many things we can do right now that don't require AI, both personally.
So right now the toolkit that you can use legally is do what your mama told you. So don't overeat, sleep abundantly, exercise, and don't stress too much.
And as a society.
Life expectancy for people who are doing well, educated, having money is much closer to 85, 90 years old already, without even drugs, right? Without special drugs. And it's really the poor people that need help, and help now.
Moreover, the debate on increasing our lifespan misses a more important point. The researchers I talk to are not really trying to find a drug that makes us live longer, but healthier. They're not really focusing on increasing our lifespan, but our health span.
People are saying, all I care about health span. I said, but I have bad news for you. There is a side effect. You might live longer.
It's kind of disappointing, don't you think, to think that maybe a few generations from now, people will live much longer than us. How do you feel when you think about that? That we just maybe might have missed it.
There are trade-offs. I mean, my generation is married for over 30 years, right? This hasn't happened in evolution. And not everybody can sustain that, right? And people are saying, so what? I'll live another 150 years? Really? Eventually, I'm not going to get divorced? You know, how is it going to happen?